Okay, let's solve the problem A. So the first fact comes to mind when you see this problem is V is for sure a superset of Y. So Y is a submask of V. So first, we need to find a subset of X, a V less than or equal to X that has Y as its subset. And then, so consider that we have some Y that is subset of V. So now, what is the largest possible set that satisfies the conditions? First, this set must have or V and X or Y. So first, let's remove Y at all, and we want to find some set that or of its elements is V and the size is maximum. What we do is simply writing all of the possible 2 to the power of number of set bits of V. That's it. So we will include 0 and also V and also all of the submasks of V, like consider VB6. So let me show you something like let V be something like this. So it's 11. So what we will include in the set would be this and also this and also this and also this and also all these four like this. So as you can see, V has 3 set bits, and here we have 8 numbers, which is equal to 2 to the power of 3. So what happens when we want X or of these numbers to be Y? The result is we can simply remove Y in our set. Remember, Y was a submask of V. And we know that when you XOR all of these numbers together, you will find all zeros. So what you need is just removing Y, and then XOR of remaining numbers will be Y. The only exception is when Y is equal to 0, that we don't remove any number. So everything seems good to go. So let's review. We need to find some V which is less than or equal to X. We should have Y as submask, and then answer is 2 to the power of pop count of V. So number of bits, number of set bits of V, then minus 1 if Y is not 0, otherwise to the power of pop count of V. So the only thing that remains is finding V, and that's it. So we start processing all these problems. We can solve them like this. So we process bit by bit. So we write X and then Y, and they start from left, and first we see some zeros. Then consider the first difference. So they come with some 0 and some 1 and 0 and 1 and so on. So let me come with some example like 3 0. Let's come with a better example, a bigger one, like X is 10 and Y is 12, vice versa actually, like this. Then X would be 1 1 0 0 and Y will be 0 1 0 1 0, and the first difference is here. Okay, so take the first difference. If when you see the first difference, if the bit in Y is actually more than the bit in X, that's it. So we can't find any answer, because there is no V that satisfies the condition that Y needs to be submasked. That's it. Otherwise, what we see is we have some 1 in X, and the same bit in y is 0. In this case, what we do is we go to the right and find the first 0 in x, and then, like, consider the example to be like this. We found the first difference here. We continue until we find some 0. Then we turn this 1 into 0 and both zeros to 1. Why? First, note that we wanted to maximize the number of set bits of v, and that's why we are doing like this. Second, we wanted that v should be less than or equal to x, and we are also satisfying this. So that is what I'm gonna do right now. So let's code. First we will read t and we'll go for the rest. Okay. Actually, this part was useful. Let's not remove that. We read x and y. Then I define some b, which is maximum number of bits. Then we start from the largest bit, and I come to list significant bits. And now let's put this if here, that if y is larger than x, for sure answer is purely -1, and that's it. Otherwise, if the ith bit of x is larger than ith bit of y, I set same to true. Then if we see some bit, we need to find the first 0. So if we see some bit that is bigger than that one, and also this bit is 0, now what we do is going to be removing the bit to the left of this, and then we need to set all of these bits. So like this will work, hopefully. And finally, we will see out 2 to the power of, let me make sure they are LL, because it won't work otherwise. I'm gonna see out top count of x. Actually, I need to cast it to unsigned long line. Minus y is not 1, because if I'm sorry, y is not 0, because if y is 0, we are not gonna decrease it by 1. Let's see what happens here. And this needs a break here, I think. Let's run again. And also let's print x and y to see what is it finding? Okay, 2 to 2 to the power of 2 to the power of 1. I had the wrong assumption, I think, because XOR of these elements is not 0, while I thought that it would be. Wait, it's happening. So I think this only happens when there is a single bit. So when there is only a single bit, what happens is the XOR will be that number exactly. But if it's more than one, yeah. So this seems like a corner case, we need to fix it. So for fixing this corner case, let's see when it happens. It only happens when V has 1 and only 1. If the X we finally found has only 1 bit, then answer will be the vice versa. Otherwise, this is the answer, and let's check. This will print the correct answer for sample test case for sure, but let's submit to see what happens for the rest. Roll A, and then we go for submitting like this. Let's see. Okay, we got AC.
Thanks for watching. If you found this video useful, please like, subscribe, and ring that bell. By the way, YouTube thinks the video down here is just perfect for you. Give it a watch and let me know in the comments.